In this video, we're going to go over how to solve multi-step inequalities, and we're going to go over how to check our solutions. The general idea, as with other inequalities that we've solved in the past, is when you have any number of steps to solve an inequality, you want to treat those inequalities like an equation. You're isolating a variable, just like equations. But look out for where we need to switch the inequality sign, right? The direction of it when we multiply or divide by negative numbers. So without further ado, we're going to use that mindset to jump into these problems. Let's rock and roll. So the first problem has one heck of a juggernaut on the left-hand side. But like with any multi-step equation, we are going to first simplify what we can and then isolate the variable. So we have 4 times the quantity y plus 1 minus 11y is greater than or equal to 39. So from here, I'm just going to distribute. So 4 times y, 4 times 1, 4 times y is 4y plus 4 minus 11y, and that is greater than or equal to 39. So I've just done some distribution. Then we're going to combine the like terms on the left-hand side. 4y minus 11y, right? Those are the terms that are combined. I'm going to do this mentally now. Gives you negative 7y. Just a kind reminder that the sign that immediately precedes the 11 comes right before it, belongs with the 11 throughout. That's why it's 4 minus 11 is greater than or equal to 39. Oh, nice easy two-step inequality here. I'm going to subtract 4 from both sides. Not so bad. That isolates the negative 7y and gets rid of plus 4. So these cancel and we're left with greater than or equal to 35. And finally, look out, there should be an alarm going off in your head. You've got a negative number times a variable. We're going to divide both sides by a negative 7. So even before I simplify, I recognize I've divided both sides of the inequality by a negative, therefore the inequality sign switches to less than or equal to from greater than or equal to. I've got the y's, or the y is now isolated. It's less than or equal to negative 5. Now, you're not asked to graph the solutions. You've done plenty of graphing in previous videos. But you are asked to check your solution. So how do you do that? Well, there's 2 things that we do, and I'm going to go over how to check your solution in this problem alone, and you can do the same exact kind of checking in numbers 2 and 3. But I'll go over how to check your solution in this problem. You want to check 2 things. The first thing is that we actually solve for the correct value. To see if you did that, you plug negative 5 into the original expression and see if we get equal to 39. So let's do that. So I'll put a little check mark. We've got 4 times, and I'm going to do some mental math here just to abbreviate the process. 4 times negative 5 plus 1 minus 11 times negative 5. And we want to know, does it equal to 39? Well, negative 5 plus 1 is negative 4 times 4 is negative 16. Negative 11 times negative 5 is positive 55. And that is a true statement. Negative 16 plus 55 is equal to 39. Sweet. So what that means is we know that we've solved for the correct boundary number, right? Negative 5. Now to check to see if our inequality sign is going in the correct direction, you should pick a number that is less than or equal to negative 5 and see if it makes for a true inequality. So I'm going to pick like y equal to negative, I don't know, 10. Make it a little bit farther away from negative 5 so there's no question. I'm going to do this mentally. Negative 10 plus 1 is negative 9. Times 4 is negative 36. So I'm kind of keeping track of those numbers here. So that's negative 36 we get from here. Negative 11 times negative 10, we're plugging in, is positive 110. And without doing any math, you can look at this and say, wait a second, negative 36 plus 110? Oh yeah, that's definitely greater than or equal to 39. What that tells us is that our inequality sign in our answer is correct. So we've checked to make sure that negative 5 is the correct boundary, and that the inequality sign is facing the correct direction by picking a number that is less than or equal to negative 5 that makes the original inequality true. Sweet. Okay, so in the next 2 problems, I'm not going to go over how to check. I'm just going to go over how to solve them. You've got how to check it right here. I'm going to erase this just so we have a little bit more room. So I'm going to erase that check as I do this next problem. Alrighty then. So number 2. 7n plus 2 is greater than 15n minus 6. Let's solve away. So 7n plus 2, 15n minus 6, I'm going to join the n's together, solving this like it's an equation. I'm going to subtract 7n from both sides. The reason why I chose to do that and not subtract 15n is I want to get the n's together and have a positive result if I can, so I don't have to worry about switching inequality signs. So I subtract 7n from both sides. The 7n's cancel on the left, and I'm left with 8n minus 6. From there, I'm going to add 6 to both sides. So I add 6 to both sides of the inequality, again, treating it like it's an equation until, well, the very end. So the 6's cancel out, and I'm left with 8 is greater than 8n. And now I'm going to divide both sides by 8, noting that there's no negative sign being involved here in the division, so we're all good. I divide by 8. The sign's going to stay the same. 8 divided by 8 is 1. So 1 is greater than n, or another way of putting that, n is less than 1. That's it. Again, how to check it? You'd plug 1 in. 1 times 7 is 7, plus 2 is 9. 1 times 15 is 15 minus 6 is 9. So that's the correct boundary. And then pick a number less than 1. An easy number less than 1 would be 0. 0 times 7 is 0, plus 2 is 2, which is greater than 15 times 0 is 0, minus 6 is negative 6. So when we plug in 0, we get that 2 is indeed greater than negative 6. So we know our inequality sign is correct and that our boundary is correct. I said I wouldn't check, but I couldn't help myself. Okay, final problem. We've got a juggernaut again. Let's deal with it. So we've got variables on both sides, but first let's deal with the distributive property. All you have to do is treat it like an equation. Again, so I'm going to multiply everything by negative 6. Distributing, negative 6 times 2 is negative 12r. And negative 6 times positive 2 is negative 12. And that's less than or equal to negative 2r plus 18. Okay, so from here it's up to you whether you want to add the 12r or add the 2r. I choose adding 12r because that's going to make the r values positive. So I'll join the variables together. Solving it like an equation, the 12r and negative 12r cancel, leaving me with negative 12, that negative sign stays, equals, or is less than or equal to, 10r plus 18. I just did negative 2r plus 12r to get 10r. Then I want to isolate r, so I'm going to subtract 18 from both sides. Minus 18. Minus 18. So the 18's cancel and you're left with negative 30 is less than or equal to 10r. From here, I want to isolate r, so just like any equation, I divide both sides by 10. Notice that we are dividing both sides by a positive 10. I recognize that 30 is negative, but we're not dividing by a negative number, so the inequality signs do not change direction. 10's divide out, negative 30 divided by 10 is negative 3, is less than or equal to r. And some people like to rewrite it like this, r is greater than or equal to negative 3. That's it, peeps. We went over how to check our solutions, both as what number we got out, as well as the direction of the inequality sign. And we saw that solving inequalities, no matter how many steps there are involved, are just like solving equations, but we got to keep in mind the direction of our inequality sign. That's it.